I'm CK. Tonight we're going to do another module from Befaco. I've had great success both building and then using the Befaco modules I've done so far. You can see the build videos on this channel. So I decided to try something interesting from them. It is the Befaco Muxlicer, like mux and slicer combined. I'm going to read from their website what the features are to make sure that I get it all right, because it's a complicated module and looks very much fun. First, route any modular signal from one in to up to 8 different outs. In other words, it can work as a multi, but it also goes the other way, or vice versa, so it's 8 to 1 as a mixer. Generate CV and gate signals, being able to work as a sequential voltage source, in other words, a sequencer. Cut audio signals into rhythmic slices with independent volume. Generate complex and dynamic patterns from any audio or modular source, or modulation source, sorry. Create powerful gate sequences with control voltages, re-triggered for each step. Can be very, very interesting. Select easily when your signal acts on your patch with the address function. So as you can see, this is a interesting module. It looks like it's going to be a rather complex build, and looks like it's going to be a lot of fun. So I'm looking forward to building it and then putting it in the rack and giving it a try. Hope you enjoy the video. So let's see what's in the bag. Also, I've got to be careful to see what's not in the bag because the bottom of the bag is ripped. I don't think any components fell out because they are in their own individual bags, but we'll see. I'll double check the parts list pretty well. And my typical flailing to get a Ziploc bag open. Take out the paper first. Got 2 stickers this time. The Nerly's inside sticker, which I've already got a bunch of, and a little wiring crazy from Befaco kind of sticker. I like that. I'll put that up on the sticker wall with everything else. So I'm going to look at the paper first. Toggle switches in the front panel, and here's the board layout. Now let's look at the interesting bits. Okay, first we've got the front panel and the circuit board. Let's take a look at this. We've got different addresses, address selector, something, I think that's a runs loop, I'm not sure. Gate mode, speed, clock in, clock out. That looks like run or loop, but I don't know, I haven't looked at the actual user manual for crying out loud. 1, 2, 3, 4, 5, 6, 7, 8 faders. Then some LEDs and gate. I don't know whether that's input or output. Then all in, common I/O, all gates, EOC. I don't know what that would mean. And then mux IOs. So that's the front panel, and behind it will be this board. This is a pretty densely packed board. Befaco does tend to pack their componentry a little more closely together than some other manufacturers or board designers. The other thing that Befaco does, and I actually asked them about this, they never actually wrote back to answer that question. They answered the other question I had. I'm going to zoom in a little bit on this. The traces meander. I mean, they don't have bends at angles, but they have very meandering, like little rivers, little streams running across. And I don't know, first off, I don't know whose board layout software actually does curvy lines like this. That's kind of wacky. Oh, look at this one, for example. I hope you can see this. This trace is thick, and then it thins out, and let's follow it up. Oh, it's just going to the chip. But the curliness of the traces just always amuses me, and or it not amuses, it intrigues me. I don't know why they do that. But let's go back up, and as is usual, the holes are all through plated, which is good. Means your chance of having a cold solder joint are very much reduced. The values are not on the board, just the numbers like R3, Q6, and so on. One challenge, because they dense pack, is sometimes the dense packing can cause the silk-screened identifiers to run over each other. However, I am not seeing that problem anywhere. The power connector is here, and then here is an expansion port. I don't know what goes in there. I didn't look on their website to see what I could expand. And it specifically says, not for power, exclamation point, exclamation point, exclamation point. So don't mess up, folks. And then the ICSP to program the chips if you want. And the chips, 2 DG408s and an AT-Mega, that's the microprocessor. The DG408s, I'm not familiar with the DG408. Let me take a look. Okay, they're 4 and 8 channel, dual 4 channel, high performance analog multiplexers. So that's where the 8 to 1, 1 to 8, and so on magic is going to be happening. So it's Muxlicer version 1.3. Of course, here it says Barcelona Earth Pig. I'm all in favor of that. Interesting. Oh, okay, they're just making sure you know this line is where the red stripe goes, where the minus 12 volt rail starts. So that's the board and the front panel. That's very interesting. Now, what Befaco does is they take their bags, they bag parts in the order that you're going to be putting together. So bag A has all the resistors, the diodes, and the ferrite cores. Let's see what else we've got. Standard eurorack cable. Bag B with all the capacitors. And actually it's not all the capacitors, I don't think. Well, it's capacitors and voltage regulators and transistors. Switches and LEDs, and another thing that Befaco does that I have not seen others do, they use, come on, tweezers, play along with the game. Put that against a white background. They use LEDs with a shoulder and then a narrower part that actually pokes through the front panel. There are the ICs and their accompanying sockets, and they're all rectangular hole sockets. Excuse me, I gotta clear my throat. Then we've got some more mechanical components, some knobs, and these are the plastic parts that will go on the faders, and Befaco Neuralese, all the jacks, and the pretty burgundy colored panel nuts. Then all the faders, and as usual, Befaco also gives you a panel nut wrench. So that's it. As you can see, there's a good bit of stuff here, not overwhelming, but enough stuff to keep us busy and occupied and happy. So time to heat up the soldering iron and get to building. I have to use my aggravating PCB holder. So the first thing we'll do is do all the resistors. So it is resistor time. Alright, resistor time is over. Next will be the diodes. And there are 7 diodes. Okay, now we're going to do the 2 ferrite beads, and they, again, they're going to be near the power supply at some point because they're mini inductors, or power input. And here they are, they go here and here. So if you haven't done this before, you take the little ferrite beads, got a hole in the center, put one of the resistor leads you saved from earlier from clipping off through it, bend it just like it's a resistor, and put it on the board. And do the other one. And the symbol that he's using is F, as in F1 and F2. Different board layout software, there's some that will actually just use the word bead, B-E-A-D, for ferrite bead. So you look at the build guide or the bill of materials for the kit you're working on to see what symbol they choose to use. Why is my iron running low? To see what symbol they use for ferrite beads. And some kit designers use them, some don't. Okay, so that's bag A all done. All the resistors, the diodes, and the 2 ferrite cores. And that'll be it for this evening, primarily because I spent the day in San Francisco, and that means the cats didn't get their treats at the right time, so they're mad at me, so I gotta go give them something to eat, or else I won't be able to, they won't let me sleep. So off to feed the cats. Next will be the sockets for the ICs. So that's that, and now we're going to do the capacitors. And now the oscillator, or crystal, 16 megahertz. And transistors, we've got 5, 1, 2, 3, 4, 5 of the 3904s. And then 1 3906, and that's that. Now, the Q4 silk screening is a little ambiguous. It's right here, and as you can see, the top circle, I guess that looks, yeah, okay, it's not as ambiguous as I thought. The flat side is on the one side, then the circle that indicates the round back also has a break in it, so that helps to identify a transistor. Now we'll do the voltage regulators. There are two of them, and one thing to point out here, they go at IC 2 and IC 3, and as you look at the silkscreen, you can see they look very much like transistor outlines. Note, don't get them confused with where the transistors go. The legs are splayed on the voltage regulators, and the circle is not broken at the back on the silkscreen. That's where the voltage regulators go. Then 3 electrolytic caps. The capacitor holes are very, very close together. Right here, C14, these holes are incredibly small. I mean, look at the typical, and that's the legs of the capacitor. So what I'm going to do is I'm going to take my needle nose, and I'm going to take this bend out of the capacitor legs. And it's not just because they're cramped between these two components. This one up here has a lot of room to breathe, but it is also very, very pitched very, very close. So we'll just, and also they're riding up against the ferrite bead there, I mean the diode there. I can probably move that a little bit. There we go. Because that's too close, in my opinion. That diode and these two caps are spaced too close to each other. And now we're going to go into the next step, which is starting the mechanical bag in bag C. Now we'll put the little dip switch in. The dip switch changes the voltage needed for address changes, which we'll talk about later when we actually run this thing, from 5 volt to 10 volt. Try and get where my solder went. Solder one leg. Take a look, and it's, as you can see, it's tilted. So I will just put my thumb on it, reheat that leg, and now it's perpendicular. Now we'll put the power connector on. Nope, that's not the power. Power's down here. See, I was trying to see if you were paying attention. Seeing if I was paying attention. Now we've got some pin headers to put on. A 2x3 at the ICSP, which is for programming. Which we probably won't do, but we'll put it on the board for completeness. And because this is only a 2x3, my finger covers all the pins while I'm holding it to solder, which means I will burn myself. Ow! Ow! but it's perpendicular. The other pin header is the expansion port, and that we might use. I mean, I'm intrigued after I get this working right out the with the capabilities it has initially. I will take a look and see what the Befaco has for expansion, or what plans they may have for expansion. Okay, so we are done soldering on this side of the board. Except for there's a serial connection here that we don't have a pin header for or anything else for, I don't believe. Now, this is the only thing that these faders I don't like them. I find them to be, I mean, they move smoothly enough, but they're bulky. I don't like the quality of them. The shafts are also too long. They use the same ones on the ADSR, their ADSR. And again, I'm being very picky here, but I'd love to find another fader solution. Now we'll start putting them on the board. And again, I'm going to take it out of this jig because the faders go all the way to the side. So they've got 4 side pins and index pins. 2 index pins on this end, 2 electrical pins on this end, 1 on that end, so you can't get them wrong. If you take a look here, there is a slight lip here and here that keeps the fader from going all the way onto the circuit board, and that's great. But what you also have to do is you have to kind of look underneath and see if any of the solder joints are keeping things from going completely flat on the board. Actually, maybe not. No, we're riding on, you can see if you look here, I can rock it a little bit. So it's rocking on the solder joints on these IC pins. So we're going to have to go through and use the flush cutters and really trim them down under all the faders. So I'll show you what I mean is you're going to come in and just nip it down to the level of the board, but by doing that, there, see, I'm pushing with both thumbs and it's not rocking anymore, so that's what you want. So I've got all those down, and I've tried the fader all the way across, and none of them rock. One thing I will point out is you're also going to have to trim the legs of the 2 pin headers. You're going to have to flush them down too. Now we'll put all the faders on. This is another thing that Befaco does, and I know it doesn't matter too much because this is non-conductive. These are just support things, but see how close they shave the edge of this PCB? You can actually, it's so transparent you can see the leg of the fader. Making sure they're all level or in the same plane with each other. This one's up a little bit. I'm going to see if I can get this one shoved down a little bit. out on the one side, and yeah, there we go. Now everybody's level. And that's all the faders. Now, one thing you do have to, of course, be aware of as you're doing this is, since these are on this side of the board and your soldering iron is on the component side, you got to make sure you don't accidentally touch other components, because you might apply too much heat on them. And we didn't solder enough to wipe out the Barcelona Earth Pig. Again, I do not know what that means. Now, the rest of the components are, of course, your typical front panel components, your faders, the jacks, and all that. And as we typically do, we will put them on the board, but we will not solder them yet, because we want to make sure we get their alignment right when we put the front panel on. So this is a rotary encoder. As you can see, it's, or maybe can tell, it's a notched rotating switch with a little push detent in it, where this is a regular potentiometer, turns smoothly. So where does it go? So the rotary encoder is at switch 1, and it's kind of funny, he's got it kind of angled on the board. And these have retaining legs, which don't work too well in this case, but that's not a big deal. I'm saying because he says there's one potentiometer, but I've got two potentiometers here. There's a comma here separating address P and multi-P, and that's what I had missed, because I can see there's spots for two of them. And another pin a little bent. Okay, so they sit in there very snugly. Oh no, there goes my water heater. Now that the pots are on, it's time to put all the jacks on the board. There's a lot of them. Get the PCB holder out of the way. We won't need that anymore. Actually, I'm going to go a little bit out of order here, because I'm going to go into fast motion here pretty soon. So we've got one toggle switch, and he does emphasize that the switch could be a tight fit. So it's the tightest fit on the through the front panel. So when we get ready to assemble everything, we'll have to be careful to make sure that slides on well. And it goes here. It'll sit just like that. And now we also have all the LEDs that go as gates on under each MUX I/O section. Positive, long leg to the left. Now I'm doing this, typically the instructions indicate put the LEDs on after the jacks. I find a number of kits have done that, but I prefer to put the LEDs in before I'm having to deal with a jack being right next to it, because I can get at the holes more easily and drop them in without having to fuss too much. If the jacks are in place, then I'm working more at a distance conceptually. So I'll just drop all the LEDs in their place. Okay, I'm going to go into fast replay as I put these jacks in. Okay, there's all the jacks on the board. Now let me seat everything. And now comes the exciting part. Getting everything to line up. Always the most interesting part of a eurorack build, not the hardest, because there's certainly some tricky soldering spots on some boards and so on, but this is the most fiddly thing to do. And again, this switch has the most resistance on it, but this went together very well. Still a little up on the top, so we use our pointy thing to adjust everything. Now we're all good. Come back a little bit on that. Now, the next step is to solder everything down. Of course, first I like to look and see who's driving heights. So the highest component in this build are the between the PCB and the front panel are the jacks. The jacks are driving the height, which means if you didn't have any jacks up here, you might have to fiddle around to make sure that the front panel is parallel to the PCB, but on this one you don't, because you have jacks all around. So what I am going to do next is I'm going to solder a couple of points along the way here while holding the board together. It's a little more challenging with these faders, but let me set it down like so. And one set of soft jaws at the other end, like so. Now it's not going to come apart and it's not going to sag. I'm going to set it down like so, and get a piece of solder. And I think I'm going to solder these two jacks, one pin on them, then come down to the other end and do one pin on each corner of the jacks down here. And then look at the color scheme, because I'm at the point where okay, because Befaco's got black and burgundy panel rings, panel nuts, so I want to match that. Don't have to, of course, but I want to. What is this? Oh. Okay, so we've got 2 and 2, so I'm going to flip back over. And I'm going to put panel nuts firmly down, as firmly as I can get, with my fingers without using the wrench. Okay, so now it's all held together pretty firmly. Nothing's going anywhere, and I can go ahead and solder. The other thing I'm going to do before I actually do the soldering is make sure all the faders run smoothly and don't appear to be interfering with the sides, and they do not. Now I'm going to solder 25 jacks and the other pots. Alright, all the jacks and pots are soldered on the board. Now a couple of things. These jack pins are right touching the power connector, so you're going to melt some plastic when you do that. Also, to get in here you have to be very careful of this film capacitor. Same as up here on the rotary switch here, you're close to this, and over here on these leads you don't want to touch the diodes because they're pretty heat sensitive. The only other interesting thing here is these clips on this potentiometer, rotary encoder, there's no solder pads on the board for these, so they're just clipping. You can't reinforce it by putting some solder on there. I wish it did have a little plating around there so I could lock it down to the board, but you can't. So next we're just going to push all the LEDs through their associated front panel holes. And a final look at everything to make sure every connection is soldered. And I take a little index card, or this little envelope in this case, and I slowly pass it over so my brain is not overwhelmed by looking at the whole board at once, but I can just look at sections at a time to reveal themselves to me. Okay, that looks good. So one other thing that, well, I'm going to go ahead and run the panel nuts down too. And again, we don't really need to see me put panel nuts on the screen, so I'm going to turn the cameras off for this next little bit. All the panel nuts are on. Now we'll put the ICs in. And they're pretty easy, you don't have to worry about confusing them. There's two DG408s, there's the processor, microprocessor, and there's this is a TL072CP little op amp. No pins bent, all in. Then these little multiplexer chips. Oops, don't get away from me, little multiplexer chip. Well, you can't see out of frame. I'm bending the pins in a little bit against the side of my workbench. Did I do that backwards? Oh no, I put this socket on backwards with the notch at the wrong end. Fortunately, it doesn't matter. You can put them in right anyway. Now I use the side of my bench to bend pins in, because you can do it even for large chips. You can get them all at once without no muss, no fuss. Where when you try and use needle nose for something like that, you can definitely make a mistake and bend some pins in far enough, some pins not in far enough there. All the chips are on board. We'll put the connector in, making sure red stripe is with the stripe on the board and the key is correct, so that's good. Now, very last thing, we're going to put all our fader knobs on. And see, this is what I don't like about these. See, with the fader knob on, there's still 5 millimeters of silver fader arm there, and I don't like that. I wish they had some shorter arms to use on these. That's the way it looks when we're done. Front, side, back. These connectors are of course not used. Other side, top, and bottom. So there it is, and again, it went together well. It's a quality unit. Now we'll go ahead and put it in the rack. The only thing I have at all complaint with is this rotary selector with the push is also a tap tempo, and it's awfully stiff for a tap tempo, but that's nitpicking. So we'll get this set up in the rack, and I'll figure out how I want to demonstrate how it works. That may take a little bit because it's complicated, and I want to do it justice without going too far into the weeds. So we'll see you in the rack in a couple. So here it is in the rack, not turned on yet. I haven't turned anything on yet, so you will see it catch on fire at the same time I do. I want to talk a little bit about what I'm going to show, because this can be a really complex device. So let's just go over what this thing can do, reading from the user's manual. Route any modular audio or CV signal from 1 in to up to 8 outs. So that would be coming in here, can go to all these outs, or you can do any combination thereof. Generate CV and gate signals, being able to work as a sequencer. We're going to try that first. Cut audio signals into rhythmic slices with independent volume. I haven't looked in depth at that yet. Chop different audio signals in a rhythmic way, and generate complex CV gate patterns from any audio or CV moving signal. So first, we're going to make sure the volume is down on the pile amp, and we'll turn everything on. And we're going to have this. You can see there's one LED lit, so it's actually powered up. We're going to have the Muxlicer feed envelope to this Danisound VCA and voltage to this a.k.a. Systems VCO. Okay, we're going to start with a simple sequence. These sliders are set to control voltage going to the VCO, and I'm going to be triggering start and stop with control voltage here from my MIDI keyboard in a Befaco Midi Thing. So if I tap the a key. You can see we're stepping through all the sequences, all the note values. Let me trigger it again. Now before I let that finish out, I'm going to speed it up a little bit. I'll hit the tap tempo pretty quick. Now we'll try it again. Now we'll try it again. Change the... Well, that doesn't have any effect right here. So that's using it as a basic sequencer. Obviously you can loop around and do other things if you have it configured right, which I don't right now. Okay, I did two things while we were off camera. I changed the switch in the back. There's the blue switch up in this corner. I changed that to 5 volt for the CV output because I want a little more control on range here. Yep, no, that's the input, not the output, sorry. Now I think if I press this and turn, no, that's not giving it to me. Okay, it's this one. This is the one that's controlling how many stops, pulses you get per sequence. So I'm going to slow this down a little bit. Speed it up again. So that's pretty neat, just for the simple having a sequence run across and being able to obviously control pitch in real time, but also divide the signal. Now we're going to do something a little different, play with some other things. This will be the last demo I'm going to do because this thing is very complex and I could go on and on, but I won't. So if we go into play, and we're running all the sequence. Now I'm going to connect to the Division 6 sequencer to the address, so the CV coming out of the note value here is going to select which step to fire off. Now as you can see, it's because we're bouncing between 2 or 3 notes here, it's only firing those steps off. Now I can change the perception of this machine's handling of the voltage here. As I go up, it will move it up the scale as to which steps the sequencer is actually triggering, if that makes sense. Now I'm going to do one more thing. As you can see, we're coming out of this, we're using this step a lot. So I'm going to take that step's gate and put that in as a modification to the FM frequency modulation on the oscillator. And of course I can change the speed of the sequencer. which doesn't affect it much because it's in conflict with the speed of this. So you can get some interesting random effects that way. And then of course we can always change this to double things up. And go faster. And then change, if I change to my top sequence here with a different sequence, a not very interesting sequence in fact, well we'll just ignore that. So we'll come back out of that. So that's what the Muxlicer, that's a brief introduction to what the Muxlicer does. It can obviously do a lot more. I haven't even covered going in and then repeating that like a multi across all 8 outputs, or having all 8 outputs feed into the common as you would if almost acting as a mixer, as well as slicing in between other sounds or slicing sounds and so on. If you're interested in this, it's a good build. It's high quality, as Befaco usually is. It's got a lot of depth to it. You can play with this a lot, and you can, I'm thinking of it as a sub-sequencer almost, because I can trigger it. I can trigger the different patterns from anything I'm doing on the sequencer or from a MIDI keyboard, which it's not doing right now, from a MIDI keyboard or other places. So from a MIDI keyboard, or whatever, and then of course the live aspect. It's just a really neat unit. I recommend this. This is going to be a lot of fun to play with in the studio. Thanks for watching. Hope you enjoyed the video.